So we'll continue with AA HL Paper 1 Specimens Paper Section B. In case you missed Section A, link down in the description. Section B, question 10. This question was also in the SL Specimens. Yeah, I said what I want to say in the Section A video, so check that out first, probably. Anyhow, we do it. So find the derivative. That should be easy. Quotient rule. So you should be able to do quotient rule relatively easy. So differentiate the du dx. So that's what 1 over 5x times 5 chain rule minus differentiate v. Kx is k. Copy u divided by v squared. So what can we do? We can, on the top, we can factor out the k. Then we have 5x and 5x cancel out. So that's 1 minus the k got factored out over k squared x squared. So 1 over the k cancel out. So it's 1 over kx squared. Okay, easy. There is a maximum point. Find the maximum point. So you make it 0 and solve it. So you multiply kx squared to the right, it's gone. So that's not a negative. So ln 5x is 1. So 5x is e to the power of 1. So x is 1 over 5 e. E. Okay, right again. Okay, the second derivative is given. And the graph has a point of inflection. Find the point of inflection. Similar stuff. You set the second derivative to be 0. Multiply the bottom to the other side. So as you can see, since this question was also in SL, is a very straightforward question. So x is 1/5 e 3 over 2. The only thing that is slightly difficult is part D. You're supposed to find the area. I mean, they give you the area. You're supposed to use that to find k. But for HL people, it's probably easy. You integrate from P to Q. P was 1/5 e to Q 1/5 e to the power of 3 over 2. You integrate the function. What's the function? ln 5x over kx dx. Okay, this is worth trying on your own. You should try to do this. Because it's like a straightforward integration. Figure out how to do it. Give it a try. Answer will be coming 3, 2, 1. Now, it is true that usually if you see log, you do by part. But this one is the only case where you do substitution, when you have log over x to the power of 1. So I think you should let u be ln 5x. Then if you differentiate that, you got 1 over 5x times 5, so that's 1 over x. So if you make dx the subject, you have x du. So this x would eventually cancel this x. That's why substitution. It'll be nice if we also change the limits. Let's change the limit. So when x is 1/5 e, u would be ln 5 times 1/5 e because of you're just substituting. That's what? That's ln e, so 1. When x is 1/5 e to the power of 3 over 2, u is ln 5 times of that. So the 5 and 1/5 cancel out. U ln e to the power of 3 over 2, that's 3 over 2. So that's changing the limit. Then we can do it. The limits becomes 1 and 3 over 2. ln 5x is u over kx dx is x du. I mean, some of you can probably do substitution faster than this. Take out the k. The k is a coefficient, just a number. But I would do it the usual way. This way is not too slow for HL math. Time is usually not a problem for most people. Obviously, you plug in 3 over 2 squared over 2 minus 1 squared over 2. In question sets, the area should be 3, so this equal to 3. So that's 3 over 2 squared is 9 over 4, divided by 2, 9 over 8, minus 1 over 2. 1 over 2 is 4 over 8. 5, 8. So k would be 5 over 24, I believe. Okay. Not hard at all. Which is fine. It's the first question of section B. That's usually easy. The second question of section B look like a complex number question. Explain that in Euler form. So you probably know Euler form is pretty much the same as polar form. You do the same thing. You find the modulus, find the argument. The modulus is a squared plus b squared square root. That's 9 plus 3, I believe. Square root, so it's root 12. The argument is arc10 root 3 over negative 3. That's the same as negative 1 over root 3. So 1 over root 3 is special. Tangent 30, I believe. Tangent 30. Tangent 30 is 1 over root 3, but this is negative, so we need tangent to be negative, so it's here or here. So this would be 150. This would be 330. Which one should we choose? The complex number is negative 3 plus root 3i, so it seems like it's in quadrant 2. So it's 150. Change 150 to radian. That's what, 5 over 6, I believe? 5 pi over 6. Okay, so the Euler form would be root 12 e I 5 pi over 6. The roots of, so the cube roots of that is u, v, and w. Find them. Okay. So let's change color. The z cube would be root 12 e I 5 pi over 6. Now, so the u, v, w are the cube root of them. So it's like you cube root this. How should I write it? Like this, and you cube root this. Square root of 12, cube root, how should I write it? Maybe 12 to the power of 1/6. Okay, because square root 12 is half, and then you 1/3 it, so you multiply them, that's 1/6. The other one would be EI, you also multiply them. That's like 5 pi over 18. That's the first one. The second one would be 5 pi over 6 plus 2 pi and then times 1/3. The third one would be 5 pi over 6 plus 4 pi and then times 1/3. So it's 18. What's the second one? 5 pi plus 12 pi, if I get common denominator, over 6 over 18, 5 pi plus 12, 17. This one, common denominator 24 plus 5, 29 pi over 18. Okay, so simple addition. Hope I get it right. Now the problem is the question don't like the argument to be too big. So this one is probably too big. So what we can do is we can take away 2 pi from it. It's the same, right? So we'll take this one away, but we place it by 29 pi over 18. Take away 2 pi. That's the same as, what's 2 times 18? 36, I believe. So 29 minus 36, that's negative 7. Like that. Okay. Okay, that is new, I believe. In the old syllabus, we usually don't see this restriction. They usually don't mind how your argument look like. Okay, be careful. Okay, so those are UVW. On an argon diagram, those are the points. Find the area of the triangle. Okay. So roughly it's like this. 5 pi over 18. That's roughly what? Pi is 180. 180 divided by 18, that's 10, so that's roughly 50 degree. So we have here roughly 50 degree. That's the first point. Let's go U. The length of that line is 12 to the power of 1 over 6, right? That's the modulus. This is the argument. So you probably know that the 3 roots would space out evenly. So we space out the 360 degree evenly. So they are different by 120 degree. That was 50 plus 120, that's 170. Plus another 120. Like this. So this is 3 point. Find the area. How should we do it? We know the angle of each of the triangles is 120. We also know each of the lengths here. Sounds like I can do half AB side C for each little piece. Then we can, for little piece of it, then we can times 3. Okay, so it's half A, B, side. Angle in between them is 120. Let's use radian just to be safe. 120 would be 2 power of 3. And then times 3. That's what? 3 for 2. What's 12 1/6 to 12 1/6? That's 12 to the power of 2 6. So 1/3. Sine 2 power of 3 is sine 120 is the same as sine 60. That's root 3 over 2. Okay, it's not supposed to be nice, is it? What's cube root of 12? Anyway, anything we can do to make it nice? 2 times 2 times 3. I don't think so. I don't think so. So there's nothing we can do. We just multiply this 2. So it's 3 root 3 over 4 times 12 to the power of 1/3. Like cube root of 12. I don't think there's anything we can do, but that's not a nice number. Well, by considering the sum of roots, show that this is 0. Okay, interesting. Okay, what do he mean by considering sum of root? Remember that U, V, W were root of this equation. So the equation is actually z cubed plus 3 minus root 3i equal to 0. Okay, so this is a cubic equation where normal cubic equation is what? Is ax cubed plus bx squared cx plus d. So in this case, a would be 1, b is 0, c is 0, d would be 3 minus root 3i. Okay, so the sum of roots, so u plus v plus w, these are the roots. Sum of root is negative b over a. Is negative b over a, but b itself is 0, so that's 0. But what are UVW? These are UVW. So all of them have 12 1/6, 12 to the power 1/6, and then you add up the e's. Equal to 0. Since it's equal to 0, obviously we can divide this away. Then we can change all of these into the corresponding polar form. Okay? So obviously ei theta is the same as cosine theta plus I sine theta. The sine, as you will see, don't do anything. But should I write out? I don't have space. Plus, let's write under, okay? Sorry for the lack of space. Plus I sine. So this whole thing is 0. Obviously 0 is 0 plus 0i. That would mean for the left hand side, both the real part and the imaginary part has to be 0. Okay, so considering the real part, so that means you only take out the cosines. Okay, so that's why I said the sign doesn't matter. Well, actually you did prove similar stuff with sine. Those also add up to be 0. Oh, no, what I mean sine. Zero. Okay, then if you compare this with the question, we have this one with this one, but this one is negative. But that's fine because for cosine, the positive and the negative are the same. Okay, since cosine negative x is the same as cosine x. That's the question. Is quite long. Finally, something HL worthy. Yeah, nice. Then we move on to the last question of this paper, question 12. Should be obvious, a Maclaurin series question. This is the new thing about the syllabus. They moved some of the option topics in the past into the core. So yeah, you can think this should be kind of difficult, but not too difficult. So there's a function. Find the first derivative of fx and find the Maclaurin of fx up to and including x squared. Okay. So you should be familiar with the formula for Maclaurin. I believe it's in the formula booklet, even if you cannot memorize it. Okay, they use fx for Maclaurin, but technically you need to have infinitely many terms for it to be fx. So I usually write mx. So this is the formula that they give you. I will just use the form that they give you. Okay, so that's obviously why we need the first two derivatives. It's for this two, so let's do it. f prime x. We need what? We need chain rule, differentiate outside the e, just same thing, times differentiate the inside, differentiate sine x is cosine x. Okay. We'll need f prime 0, but let's do that later because the question did ask for the first two derivatives first. For the second derivative, we'll need a product rule. So differentiate the first thing first. Let's say you can do either way. It's basically what we just did. So chain rule times copy the other thing plus copy the first thing times differentiate the second thing, differentiate cosine x negative sine x. So basic product rule shouldn't be hard for any one of you. Should we take out the e sine x? Let's say we take out the e sine x, then we have cosine square x minus sine x. Okay. What do we need for Maclaurin? We will need f prime 0 and f prime 0, so sub in 0. So it's e to the power of sine 0. Sine 0 is 0 times cosine 0. Cosine 0 is 1. E to the power of 0 is also 1. 1 times 1 is 1. And then f prime 0. That's e to the power of 0 times cosine 0 is 1. 1 squared is 1 minus sine squared is 0. So it's still 1. Okay, so the Maclaurin series would be f0. Oh, we still need f0. I somehow forgot f0. The function was e to the power of sine x. So it's e to the power of 0 again. So it's also 1. So it's 1 plus x times f prime 0, which is 1. Well, let's write it out. It's a bit redundant, but let's write it out. So it's 1 plus x squared over 2. Just like that. Yeah. Yeah, for the first few terms, it looks exactly like EX. Probably a coincidence. Yeah, that's a coincidence. Show that the coefficient of x to the power of 3 in the Maclaurin for fx is 0. Oh, okay. Okay. So it's basically the next term in the Maclaurin. So if you had the next term, it would be x to the power of 3 over 3 factorial f prime 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 0. So for x to the power of 3 to have a coefficient of 0, it probably means that this should be 0. So I guess that's exactly what I was thinking. Starting from this fourth term, it will be different from e to the power of x. So we basically need to find the third derivative. Let's do it here. This is the second derivative. So the first derivative would be again product rule. Differentiate the first thing. So we did this a few times already. Copy the second thing. The whole bracket is the second thing. This is why factorizing e to the power of sine x was a good move. Otherwise, you need to do product rule twice. Plus copy the first. Differentiate the second. Differentiate cosine square x. We need chain rule with that as well. So it's 2 cosine x times differentiate cosine negative sine, then minus differentiate sine x is cosine x. Okay. This kind of thing really shouldn't be hard for an actual math student. Take out the e. Let's expand this in. So it's cosine cube minus cosine x sine x plus this. Oh, but that's a negative. There is a negative. Minus 2 cosine x sine x minus cosine x. So we got cosine cube x minus 3 cosine x sine x minus cosine x. And so f prime prime 0 would be e to the power of sine 0 is 0, cosine 0 is 1, 1 cubed is 1, minus 3 times this. But remember sine x, sine 0 is 0, so that's 0, minus cosine 0 is 1. So the 1 and 1 cancel out, so we get 0. And therefore, the coefficient of x cubed is 0. Okay, so far it's still really straightforward. It's really just standard Maclaurin, you do it. That's it. B, use Maclaurin series of arctan and e to the power of 3x minus 1. Find a Maclaurin series of blah. Okay, I don't think part C will be related to A and B. Probably not. Yeah. Really don't have much space. This should be fine. We'll do it. Arctan x. Okay. The Maclaurin series of arctan x is provided. In the booklet, is x minus x cubed over 3 plus x5 over 5 minus dot dot dot. Yeah. They only want to include up to x to the power of 3, so really x to the power of 3 should be enough. Okay, Maclaurin series of e to the power of 3x minus 1. Okay, so e to the power of 3x, if we use the formula, it will be 1 plus x. If you look at the Maclaurin series of ex, it will be 1 plus x, but now we have 3x, so 3x plus 3x squared over 2 factorial. They want up to cubed term, so we might need the cube term. So let's do the cube term as well. Dot dot dot. But remember it was e to the power of 3x minus 1. So we'll minus 1. So basically take away this one. This. And then we have arctan that thing, okay. Arctan that. Okay. So this is a kind of composite function. What we do is we plug this whole thing into all the x of arctan x. Okay. So we'll do that. So this is just for the x. For the x, it's 9x squared over 2 plus 27x over 3 over 3 factorial 6. Okay. That's for the x. Then minus over 3x cubed. So it's 3x. So put in the whole thing cube. Okay, we'll copy this for now. Cancel the 3 out. I think that's 9 over 2 as well. Then minus. Okay. Oh, this is a square, right? This should be the difficult part. We need to kind of expand this to find the cube terms. Is there a faster way of doing this other than expanding everything out? I think so. I think what we can do is we can factor out the x. So we factor out x, they got x, but that x is also cubed. So it's x cubed times 3 plus 9 x over 2 plus 27 x squared over 6 cubed. Okay, this 3 is in the way. Okay, so first of all, I did is I factor out the x. Now then, this is already a cube term. So if you multiply any more x to it, it will be of higher power than 3, okay? That means for this expansion, we're only looking for constant term. You can only afford to multiply a constant to x cubed, because if you multiply any x to it, the power would go to at least 4, and we don't care about anything of power at least 4. What is the only constant term that would come out from this whole thing? It should be 3 to the power of 3, right? Because any other thing multiplying together would involve some x. So the only term that we have is 3 to the power of 3 plus dot dot dot. A lot of term that we're omitting. Minus, what's that? 9, I think. So if we simplify, we have, what is this? We have 9 over 2 minus 18 over 2. So that's minus 9 over 2. That for up to x cubed. Okay. Yeah. Yeah. I mean, to be fair, if you don't even need to take out x, you could just say that the only way you get a cube term is to cube this, right? Because if you involve any other terms, you have a way higher power. So yeah, you probably don't even need to do what I did. Okay, that's one way though. Hence or otherwise, find the following limit. So obviously they want us to use the Maclaurin to do it. So we'll do it. So fx minus 1. Where's our fx? What's the Maclaurin of fx? I think it's this. I think it's this. Where the cube term is 0. Okay. And we need to minus 1. So it's just this. Sorry, was that too low? Okay, say again, fx is this. It's this whole thing, but you need to minus 1. So it's just this. Oh, okay, really low in Spain. What's the limit? X go to 0. Fx minus 1 over arctan e 3x minus 1, I believe. Is that right? Yeah, fx minus 1 is just this. So it's x plus x squared over 2 over the arctan thing. It was this. 3x plus that minus that. Obvious thing to do. Take out x for both top and bottom and cancel it out. So it's 1 plus x over 2 over 3 plus 9x over 2 minus 9x squared over 2. Oh, limit. I forgot to write limit. Why would I do that? No, I don't want it as the last step because we can already take the limit. When x tends to 0, this tends to 0, 0, 0. So we have 1 over 3 as our limit. Easy. So turn out, although the last question was on so-called option topic in old syllabus, it's actually pretty straightforward. And that's actually true for the old syllabus option. The option paper are usually quite straightforward. Okay, so it's not much to be worried about. Just need to take your time, study the topics. If you know how to do Maclaurin, you probably can do this question no problem. So this is it, paper 1. Comment down below if you have any questions. Check out my other courses if you need to. And also stay tuned for paper 2. See ya.